Hi, 6th level. Hopefully, lesson 1.1 went well and you're feeling more comfortable using the textbook. This week, we're going to be starting on page 10, which is lesson 1.2, talking about powers and exponents. So, as we probably already know, powers and exponents are really synonyms, and it means the same type of math. But let's just do a real quick review and go over what a power and an exponent actually is.
Let's first take a look at the number 4. We can have 4 by itself. We can have 4 times 4. We can have 4 times 4 times 4. We can multiply 4 by itself 4 times. 4 times itself 5 times. But I think that you can see the more times we multiply 4 by itself, the more space we're using up. Mathematicians have found a shortcut called exponents and powers to shorten this unnecessary repetition of numbers multiplied by themselves. And it's called exponents. So, in our first one, it's really 4 times itself just once. This is a power. It's 4 to the first power, or 4 to the power of 1. It just means it's 4 by itself. Here we have 4 times itself 2 times. So it's 4 to the power of 2, or 4 squared. Here, 4 times 4 times 4 is 4 times itself 3 times. It doesn't mean it's 4 times 3. It means it's 4 times 4 times 4. 4 times itself 3 times. I bet you can guess what this is. If you said 4 to the 4th power, or 4 to the 4th power, you would be correct. Likewise, we can shorten this up to 4 to the 5th power. Writing this is a whole lot shorter than writing that. It's clearer, it's simpler. I'm sorry, I was distracted and I do not know where I was. So we'll start here. When we take a look at 4 to the 5th power, this is actually broken down into 2 parts. The first part is called the base. The base is the number that we're actually using to multiply. Here we're multiplying by 4s. So our 4 is the base. Next, is the exponent. The exponent, or the power, is how many times the base is multiplied by itself. The number one problem that students have with exponents is they'll sometimes forget and say, oh, this is 4 to the 5th power, which means 4 times 5. This is not 4 times 5. This is not 20. If this was 4 times 5, it would not be written as an exponent. It would be written as 4 times 5. This is a short version of 4 times 4 times 4 times 4 times 4. So if you remember this, that'll go a long way to helping you with your exponent work. Now I'm going to let you in on a little secret.
And it very rarely comes into play, but it does come into play sometimes. If you remember back to working with variables, and we have a plus a. Well, it's not written, but it's actually there. There is an invisible 1 and an invisible 1. 1a plus 1a is equal to 2a. But we leave that 1 off because it's not necessary. If we just have a plus a, we know that it's 2a. So we don't need to write the 1, but it's actually there. It helps make 1a plus 1a equal 2a work. Does that make sense? We don't need to write the 1 because a plus a is 2a, but there really is a 1 in front of those a's to help make it equal 2a mathematically and logically. So sometimes we have things that we don't really write because we don't really need, but they're actually there. Well, the same thing exists with exponents. When I have 4 to the 5th power, there's actually something else that's invisible because we really don't need it most of the time. This is actually 1 times 4 to the 5th power. 1 times 4 to the 5th power. If I had 6 to the 12th power, it would be 1 times 6 to the 12th power. This part we don't really need because it doesn't change anything. This part we don't really need because it doesn't change anything. And we're left just using the exponent, the base and the exponent together. This part, while it technically exists, isn't needed, except here we have an exponent of 5, exponent of 4, exponent of 3, exponent of 2, exponent of 1. So, what is an exponent of 0? 4 to the power of 0 is equal to... Did you say 0? Wrong. It is not. Anything to the power of 0 is 1. And that's because of that invisible 1 times. This says it's 1 times 4 times itself, no times. 4 times itself, no times, doesn't equal 0. It's saying it's like not even there. 4 multiplied by itself, no time. So it's really not even there. And what we're really saying is 1 is equal to 1. I could have it times 50 to the 50 to the 0 power. It's 1 times 50 times itself, no times. It doesn't there. It's not there. It doesn't exist. Which is left with 1 is equal to 1. That's the only time that the 1 times really matters. Because if we have 2 to the 3rd power, 2 to the 3rd power is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So 1 times 8 is equal to 8. But it's the same thing if we don't even have the 1 times. 3 to the 2nd, or 2 to the 3rd power is still equal to 8. So the 1 times, the base and the exponent does exist. We just
don't need to write it because we can solve it without it. The only time we need to know is when the exponent is 0. Anything to the power of 0 is always equal to 1. Anything to the power of 1 is equal to the base. 542 to the first power is equal to 542. But 542 to the power of 0 is equal to 1. If we take 4 to the power of 2, you could also call that 4 squared. Well, why is that? If you remember back to our 4th grade lessons when we worked with pegboards and bead bars, if you had a 4 square, you had 4 across and 4 down. So on your pegboard, you had a 4 by 4 squared, or 4 by 4 square. It forms a square, and if you count all of the dots or all of the beads in there, 4 times 4 is 16. So a 4 squared is equal to 16. Because the shape is a square, the measurement on the bottom is going to be the same as the measurement on the side. Now, we know that 4 times 4 is equal to 16, but we can also use this to find the area. Let's say this is a really small tabletop. It's 4 inches across and 4 inches deep. And I want to know what is the area on the inside of this. Well, it's still 4 by 4. And if we're measuring it in inches, we know that if it was pegs, we'd have 16 pegs. But we're actually talking about inches here, so it's inches squared. We label it because we've measured in 2 different dimensions, length and a width. If we change it to 4 to the 3rd power, you've also heard that as 4 cubed. The reason for that is what we're talking about is four inches on the bottom, 4 inches wide or up and down, and forgive my art, 4 inches back. So we have a cube. And if I want to know the area of the cube, everything that's inside there, then I would multiply 4 times 4 times 4. These would all be inches. My first 4 times 4 is 16. Here's my first 4, my second 4, and my third 4. My answer is 64. 64, or 4 to the 3rd power, is 64. And if I am measuring the volume, how much space is in here, I've got all of the 16 beads on this side, the 16 beads there, the 16 beads there, and everything in between, there would be a total of 64 beads, or inches for this particular measurement, cubed. We're calling it cubed because we're measuring in 1, 2, 3 dimensions. The shape forms a cube, so something to the third power can be called a cube. Something to the second power forms a square. This information will help you with one of your assignment answers. Just try to understand it and put that answer into your own words when that problem comes up. Something like this, 2/10 to the fourth power. All that means is it's 0.2 times 0.2 times 0.2 times 0.2. If I was teaching this, I would have given a little bit of a review lesson first, but the book is going to assume you remember how to do it. Hopefully you remember this from 5th grade. If you remember how to do the decimal slide, move the decimals out of this problem to make this problem easier, because it's a whole lot easier to multiply by 2's than it is 2/10. So, if I move the decimal one place, I've turned that into a 2. If I move this one place, I've turned it into a 2. If I move this one place, I've turned it into a 2. And if I move this one place, I've turned it into a 2. So I have blooped or danced or moved or slid the decimal a total of 4 places out of this problem. I've gotten rid of this 10th, and this 10th, and this 10th, and this 10th, and made it a whole. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So 16 would be the answer if this was actually 2 times 2 times 2 times 2, but it's really supposed to be 2/10 times 2/10 times 2/10 times 2/10. So I slid the decimal out 4 places. I need to move the decimal back into my answer 4 places. Where does a decimal live in the number 16? It lives right here. We don't put a decimal in a whole number unless we need to show something in the tenths, hundredths, something that's less than a whole in its place value. If you are 12 years old, you don't say I'm 12 years old. You just say I'm 12. Same thing with the number 16. We don't say the decimal in the number 16, but it lives here. Since it lives here, and we have to slide it back into our answer 4 places, we're going to move 1, 2. I need to move 2 more places, but there is no more digits here to slide. We need to add a 0, 3, add a digit, 0, 4. So I've slid my decimal out a total of 4 places, making my math easy. Then I slide the decimal back into my answer 4 places. And so the answer is 0.0016.
6th level, this shouldn't be new, but it may be need to jog your memory till you remember how to do multiplication with decimals. It's not a big deal. I probably would not have put the decimal work into this at this point, but it's in the textbook. We can do it. It is a review for everyone in 6th level, assuming that you've been in at Westside for 5th level because it's part of our curriculum that we've had in the past. So yeah, we might just need to jog our memory a little bit to remember how to work with multiplying decimals, but that's all it is. Because it's a repeated multiplication, even if it's a decimal number, you're still repeating the decimal multiplication, and that is the way to handle decimal work.
You may end up with a problem where you do need to do long multiplication. I'll do just an easy one. So this means 12 times 12. Okay, do long multiplication. 4, 2, placeholder 0. Don't forget your placeholder 0. 2, 1, 4, 4, 1. So 12 squared is 144, and I used long multiplication. There will be some in your work where you'll have to do long multiplication. You may end up with something like 32 times 32. You'll set it up and solve it just like this. You might have something like 11 times 11 times 11. So you'll do your 11 times 11. You'll get your answer and multiply that times 11 because you need it 1, 2, 3 times. This is a hint as to how you can multiply, get your answer, keep on going, however many times the exponent is. This would be 11 to the 3rd power. So 1, 2, there are 3 times 11s in my work. You could see something where you have x to the 3rd, y to the 5th, and your instructions are evaluate if x equals 5 and y equals 2. Okay, well there are 2 different problems here. The first one, we have x times x times x, but we're saying that x is 5. So it's 5 times 5 times 5. If I set it up long multiplication, 5 times 5 is 25. Well, I've used 2 of my 5s, but I need a 3rd one. Times 5. And that's my 3rd. 5, 2. So I come up with 125. This would be 125 if x is equal to 5. My y is equal to 2. Well, really we have y times y times y times y times y. Or 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So, y to the 5th is 32 if y is equal to 2.
Your assignment for this week in your textbook. You will need to carefully read through the pages of 10 and 11. Some of that information is going to be repeated from what you saw. Hopefully this video helps support what you read. Maybe helps make some clarification. Go ahead and take notes from the textbook if you need it. Refer back to the textbook notes. Refer back to the notes that you just copied into your composition notebook. Hopefully you did, so that you can refer back to it, because it's a whole lot easier to look at your notes in your comp book than go back and watch 20 minutes of me doing this again. I mean, I could watch myself all day, but, you know, I don't expect you to as well. Your work is going to be on pages 12 and 13 of your book. instead of breaking up the exercise over multiple weeks, if you take a look at 1 through 38, 1 through 38, there's not that many there. And some of these questions are simple. Don't make them harder than they need to be. Problems 1 through 12 are relatively straightforward. They're not too difficult. Don't make problems starting with number 13 too challenging. It does say write the product using an exponent. And if I was reading that as a teacher, I would want to know number 13 says 32 times 32. I would actually try to calculate what is 32 times 32 because it asks for the product. And you may do that, but the correct answer that you will get is simply 32 squared. Don't make it harder than it is. The same process is going to be used for 14, 15, 16, 17, 18, 19, and 20. 21 through 28, it says write the power in words and as repeated multiplication. Repeated multiplication is simply 2 to the 4th power is 2 times 2 times 2 times 2. Written in words, write the power in words, that would be 2 to the 4th power written out. Pretty simple there. There will be some volume work. Remember, volume is how much material would fill an object, fill a shape. So we're talking about 3 dimensions, a length, a width, and a height. So it's a cube in essence, and make sure that your answer is written in units cubed to the 3rd power. Some of the questions you may be able to answer based on your knowledge of what you've heard, or if you took notes on what I said would help you answer questions that are coming up, you should be able to answer some of the sentence answers where it's explain blah, 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 blah. Hopefully that you can use that. So, good luck with this work. Fran is going to be hosting a Zoom conference. I believe it's this Wednesday. You may already have information about it. If not, look for it. And she will answer questions that you may have. Questions on this, questions on past work. Hopefully you can join and ask your question. If you aren't unable to join, just keep on messaging us, posting on Google Classroom, and we'll get those answers, we'll get those questions answered as soon as we can. Have a good week. Good luck, and talk to you soon. Bye, 5th level, 6th level. Bye, 6th level.